An invited guest and presenter got caught in all that bad weather they're having up north. So it's been a bit of an odyssey, but glad to have Annie here in the nick of time for our talk today. Introducing our guest, the title of the lecture today, Maximum Kick with Minimum Impact, I think follows up in a timely way on the 2010 imperative that many of you probably saw the presentation here last week. Annie will be showing the work of her firm, Anni Tilt, which specializes in ecological design, ecologically sensitive design. Annie has her undergraduate degree from Princeton University, Master of Architecture from UC Berkeley, where she was a prestigious Branner Fellow. And her partner and husband, David Arkin, also received his master's from Berkeley and spent years working prior to starting his own practice with Sim Vanderen in Sim's office, which is Sim Vanderen widely respected as a leader in the field of sustainable design. So some very impressive credentials and a very impressive body of work in the emerging practice of Anni Tilt. The work of the firm embraces 5 stated goals: to harmonize with the site, to build as little as possible. Sorry? Ah, okay. I'm honing in on the presentation. The work has won numerous awards, been recognized with AIA awards, an AIA Cote Top 10 Green Building Award recently in 2005, Environmental Construction Excellence Award. Their work is currently displayed in Washington, D.C. on a show in the Capitol building on green housing. And as I said, Annie's just joining us from an invited jury in Minneapolis where they were presenting their work as they got stuck in the storm. So please join me in welcoming Anni Tilt, and we've lost David Arkin along the way, but Annie's going to persevere and give the presentation for both of them.
Hi, can you hear me now? Well, I'm very excited to be here. At long last, just from yesterday to today seemed like about 3 weeks worth of airport and online searches for that last plane. And then I didn't tell Tim this, but they didn't accept my reservation, so I got to the airport this morning and it wasn't there. So, but we found a way. We made it. And so thank you so much, Tim, both for bringing me out here. And Tim was a colleague of mine at Fernone Hartman Architects, and I learned a huge amount from him. So I think of him as one of my teachers as well. And I also want to thank my dear friend Yvette Bruns, who is a college friend. We're both in architecture and engineering. And she put up with my shifting plans as well, and was my savior, picking me up from the airport and delivering me with a few minutes to spare, you know, more or less. Okay, this image, I just have to explain, we were actually up in Duluth. The Minnesota AIA has their design retreat up in Duluth, which seemed quite bizarre to me, but it's true that when you're out there, you're sort of, you're no longer in the city. You're sort of somewhere else altogether. Oddly enough, this bridge, one of the first jobs my husband had, he actually went to the University of Minnesota. He did the measured drawings for this bridge when he was working for the engineering survey. But what this picture is really about is this little guy down here who very entrepreneurial. He just took a blue tarp out there, and there was a big strong wind as the storm was coming up, and he sat on, I don't know, a piece of cardboard, who knows what, and zipped his way around the lake just with its blue tarp held out and some serious wind power. So there's minimum impact for you. Okay, let me start in here. don't usually like to do the doom and gloom slides too much, but this was a major story in the National Geographic in 2004 about the end of cheap oil. And I think that the implications of the using of oil over the course of time are going to become really imminent. And it actually has, I don't think we're going to run out of oil, but it's going to become a question of equity. This is from the book, Richard Heimberg's book, The Party's Over, where the correlation between world oil production peaking and an actual population, the effect on population as right now oil affects food production as well as the way of life. So these images are from a book called The Return of the Solar Cat, which is really wonderful if anyone is able to pick it up. But the sort of human solution of Burr, I'm cold, and he goes to the ends of the earth and mines everything up, builds this elaborate procedure just to, fire up his solid-state electric blanket. And what we're sort of advocating is a more simple, back to the basics approach, where the cat solves it in 2 steps. And this is our solar dog, the office dog, illustrating the point where he just follows that little chunk of sun around as it moves from the front door. Of course, ecological design is not a new idea in any way. It is only with the advent of heating and ventilating and air conditioning that we're able to manipulate our environments. So all of these buildings are responding to their climate using local materials, as well as, having some fanciful details. All this we sort of summarize in something we call maximum kick with minimum impact. And some days I don't really know what that means, but I think what's sort of an ecological bang for the buck. And so I'll just go through our goals quickly. The first goal, harmonize with the site. Really, the site is the starting place, whether it's rural or urban. Both the context, the views, the history and culture, the soil, the plant communities, wind directions, climate, all of these things come together, and that's really where we start the process. The second goal, build as little as possible. Sort of an odd thing for architects to say, but I think that if you're looking to reduce energy loads and reduce resources, if you have a smaller envelope, there's less to heat, and then you can actually, hopefully allocate that to the finances to details as well. So third goal, buildings should be able to heat and cool themselves and generate their own electricity. A little harder in Indiana than it is in California, but I still think that there's a lot of technologies out there that can make that possible, and we should at least move towards that goal. Fourth goal, maximize resource efficiency, really looking to the life cycles of the materials that we're using. Straw is a waste product, and getting the most out of each thing that we use, and not just the most in terms of thermal performance or structural performance, but also aesthetic performance. And the final goal, which we call connectivity and delight, I think really as things become more generic, as you go past another strip mall and there's another Starbucks on that corner, that having a connection with the natural world around you, and also just the cycle of the sun or the changing of the seasons, that these things are becoming, I think they're really important, and it's important to connect back to them, but also connect to history, connect to each other as people, create social spaces, and hopefully I don't need to explain the delight piece, but always trying to get that in there where there is something maybe a little unusual that you weren't expecting. That makes you think a little bit. I'm going to walk through our design process. Regardless of the size of the project, we use a pretty similar process. And I'm going to do that using a project we worked on about 6 years ago now, the Hidden Villa Hostel and Summer Camp facility in the South Bay. And it's on a ecological education farm, and they have had actually a hostel on the property since 1937. So our mandate was actually to replace it and provide the summer camp facility. So every project starts with a site analysis diagram and climate response strategies. We do these really, really simple diagrams as just a way of consolidating the information, where storms are coming from, what the views are. This is showing sun path. This is the winter diagram. Here's what it would be if it was on the horizon, but this particular project is in a very steep, narrow draw. So the actual amount of sun we're getting in the winter is very restricted. As well, the summer sun is actually cut off a little bit. If it were on the horizon, it would be here. So again, very simple diagram, but we actually refer to it a lot as we go through our design process. Oh, I didn't explain this diagram, I'm sorry. This is taken with a fisheye lens and a solar overlay on it. So we're actually understanding where the shadows are that are affecting the building. Looking at vernacular buildings, does that work? Okay, if that's good enough, then I won't worry about it. I feel like the Stepford wives. Recharge me up. Yeah. All right, where was I? Again, you know, it's always fun to look at anyway, but old farm buildings, whatnot, you know, porches, overhangs, just kinds of materials, you know, what clues can we take from these buildings and build on that. Understanding the users, of course, is very important. In this particular project, they had, doubling up to 70 campers in the summertime, and then actually in the rest of the year, it's just a hostel, so there's actually very few people. So that was something that we had to work with. And with every project, we explore options. 2 to 3 usually, sometimes 4, sometimes 8, but don't go there very often. This particular project, we explored them in models using these fairly rough cardboard models because there was a 21-member committee, and the models could convey very quickly these rough ideas, and they actually slotted into a larger site model. There's the final version of it with its context, and then we can take that and use it as a tool and do solar performance modeling on it. This at our PG&E Energy Center, which is it's the public utilities building, and they have something called a heliodon. At the daylighting lab, you have something similar? You've got a heliodon. You guys are set. Anyway, so I won't explain how it works exactly, but we're able to, I think there's a quick video, and again, these are very crude cardboard models with the idea that we can, you know, rip them apart and put them back together again. This just being a winter solstice sun study and a project on the coast. So really trying to get the light deep in the building. Great. We also do thermal performance modeling on the computer. When it's appropriate. This is actually an example from a project in China, much more challenging. And integrating salvage materials is something we always try to do, both in terms of resources, but also for the character that they can bring to a project. This particular hostel, this is an existing hostel, and was in pretty bad shape. Had lots of problems, but one thing that really everyone sort of resonated with everyone was this sort of bank of windows and doors, hot pink bank of windows and doors at the front of the building. We did end up using a lot of the siding. We intended to use the concrete broken up for the patios, but it was there was so much sand in it that it just completely crumbled. So we became fill. Fine tuning at the site. Every project we, in a you can see it's a fairly raw drawing. We'll take it out and stake it out and adjust it in terms of views or trees, or the survey's always wrong, so some large slope is different. And then collaborating with builders. Again, this is more on residential projects, obviously, but as much as possible, we try and get them involved and get their ideas about what are sometimes fairly unusual systems coordinated and as efficiently done as possible. Building workshops is something we like to do, again, when we're working with fairly unusual building systems, having a kind of demonstration project, a straw bale raising, or in this case, we actually did a rammed earth wall as a building workshop. This was actually, it was for financial reasons as much as anything, because we couldn't afford to have it done any other way. But it was great because it got everyone involved, and then there was a sort of sense of ownership of the building as well. So this is the wall that we built during the workshop. And we not only got a lovely wall, but we got this great staining on the floor as a result of the dirt being dumped in and loaded up. These are my children. They're a little larger now, but they're never afraid of the dirt. Still not afraid of the dirt. Just a quick trip through this particular project. Again, it's in this very narrow draw off of the main valley here. And it's kind of, the idea is it's tucked behind this major, they call the sacred climbing tree, so that it's a little bit off of the main path. And the entire building is pulled to the north side of this draw so that you get a sense of that canyon. Before the hostel building just blocked the end of it like a dam. So this really gives you a sort of flow up, as well as bringing sun in to these, the dining room and the manager's apartment, where things like the cold storage and the kitchen are tucked away, and sort of thermally layering the section. Just a view of the dining room with its large clerestory. All of the trusses here are salvaged fir. This is a pressed ryegrass board on the ceiling. And then even the wainscot here came from a building that was affectionately known as Ed the Shed, that had to be dismantled as a part of building this particular project. And then from the exterior, again, large clerestory for the winter light, lots of overhang, and then a really deep porch. I mean, fairly straightforward technique, but it really worked well in this particular climate. And then large steps that also form a sort of gathering space on the exterior. We were put about 4 times the amount of program into this small space. There's the climbing tree on this side, and these are existing cabins on the other side. So one of the ways we tried to do that was by pulling pieces out, and it also reduces the scale. So the bathrooms come up and are their own building between the cabins and the main facility. And then on the front side, we pulled out the office function, and so it becomes a kind of marker on that main street as well, with the again with the facility behind. Just quick trip through the heating and cooling systems. This project has a ground source heat pump, a fairly expensive system, but because of its constraints, it worked well here. Provides both domestic hot water as well as heat for the radiant tubing in the floors. Almost all of the air conditioning, or the conditioning, I guess you would say, is natural, just passive because of the high ceiling and high windows and louvers. A lot of that heat is allowed to escape. There's an additional evaporative cooler on the kitchen side for the added load from there. This is the screen porch, which is at the west end of the building, and it is both protecting from that western sun, whatever can get through the climbing tree, and providing a high vent here, but it actually opens up, oh, there's so many of them, opens up, I think I have another slide, the end of the dining room opens up into it, so that when it's a summer camp, you can actually have this larger space that's really well ventilated, but in the wintertime you're closing down and only heating a much smaller area when it's a hostel, which is what it's set up as there. The kitchen, on the north side, there's that rammed earth wall. So the rammed earth wall is also moderating the temperature from the high heat that's generated in the kitchen. And then it gets light both from these clerestories as well as a fair amount of windows on the east and west ends that are fairly protected. And there's one of those ends, and just providing, I mean, these are fairly basic things, but little seating spaces for the staffers that are away from where all the campers are supposed to be. And then a final view uphill with these existing cabins, sort of trying to create that space and keep this, again, quite large building in scale by tucking it in the hill. I think I've just got two projects talking about site, or I guess they're all about site, but that I want to particularly emphasize. This one is up the coast in a town called Wallala, where everybody has a beautiful view of the ocean in Wallala. But this particular site was quite funky. It has, I think I have a little model of it. There's a creek going right through the middle of it, and then power lines go this other direction. And when our clients, who are really wonderful builders, also bought this lot, it came with the permit somehow, I don't know. The proposal was to culvert the creek from one end to the other so that they could get the septic field in, because you need a setback from the creek, and then plonk a house right there. And we didn't want to do that. My owners didn't want to do that, and by the time we got there, the Coastal Commission wasn't going to let us. So we sat down with all these various agencies, the Health Department and the Coastal Commission, and came up with a plan where they actually reduced the setbacks to the creek and allowed us to, it's almost a zero setback on this side, squeeze a little house up in the corner, get the septic on the other side, and then the garage is split out with access down here. And then there's this really lovely path that's up along the edge of the creek up to the house. And then when you get to the top, this is a little garage for your grocery cart. You need something to move stuff in. Just a couple of shots of the woodwork here. Again, really wonderful carpenters, owners built this thing. And there's a final view of that. 1,300 square foot. Well, we can only call it a one-bedroom house, but several more. This next project has been in the office a very long time, almost 10 years, and it's unbelievably tiny, but this is a gateway facility for the Arrastradero Park Preserve in Palo Alto, California, 600 acres, and some of it is quite beautiful. The area on this side of the road, on this side it's quite beautiful. On this side it's actually quite degraded and has been overgrazed and has relatively little vegetation. So the strategy here was to work with the existing parking lot and build it relatively close to that, and then working with the land stewards, try and use it to facilitate the renovation of the park and the restoration. There's a series of small buildings, and these are sort of roughly based on horse barns in the area, which are actually always fairly petite and kind of a little collection of buildings. And these are sort of shoved into the hill. It's actually a scenic corridor, this road. So the visual aspect was very important. And actually, from the main direction, you don't even see the building until you're past it and you turn around and look at it. It's broken up into these pieces, and that what it allows us to do is have this space between the buildings, between this sort of office and a meeting room and then restrooms out here. And in this space, volunteers can gather, have access to tool storage around the edges of that space, and they can have a meeting and sort of prep while other people are passing, so that the other people are passing understand that there's something going on. It doesn't interrupt the flow, but they might get the idea, hey, I could do that next time, and therefore sort of build on that restoration process. It's a straw bale building. You don't see much of it from this side. It's all on the north side. Let me just go back a slide. You can see on these north edges are the thicker walls are straw bale, and it's completely off the grid. It has two photovoltaic arrays One is, you can just sort of see it, and the idea is that it's fairly subtle, but this is a PV laminate integrated with the roofing. And then there are these other panels that are on the front of the office building that in their winter setting, they get more sun, and then in the summer you actually slide them down for a better angle and to help shade the building. You'll see that again. We like that trick. There's a shot of it from the front. It also has these very big shutters that you can completely close the park down. It closes at sunset, so you can, you know, it has a security aspect to it as well. Just a quick shot of the interior. There was a barn that was dismantled on the preserve itself, so we actually had a lot of barn wood to use, and we wanted to integrate it on the interior as well as the exterior of the building. And then a final picture of that uphill, you can see these little straw bale walls, which actually also act as a bit of a fire retardant if fires are coming down that hill. Whoops. There's also solar hot water panel here. Is just a direct, I mean, everything is very, very simple in this building. Again, with the idea that people can see it and it's working, that they get it, and then they can take it with them. Water is something we're paying increasing attention to. I think when we started, we thought of it as more of an aesthetic thing. It's almost a building material, you know. It's something that you can work with for its beauty. And this is actually at the church, a symbolic baptismal font rock that the gutter sort of dumps onto. I'll get into that in a minute. You know, I think it's one of the things that's really going to drive a lot of development and can cause a lot of issues down the road. This particular project is the Real Good Soil Living Center up in Hopland, California. And should be a fair amount of information about this project online. And it's a project that David, my partner was a project architect with when he was with Sim van der Rijn and Associates. And Sim gives you lots of elbow room. So he had a lot of fun with this project. And this is really designed, the entire site was designed with water in mind. And ponds were excavated both for cooling and obviously for watering, but also that soil was used to build up the berm because it's actually a major floodplain. And I've seen it through a couple of floods, and it makes a difference. The building itself is wrapped around this central oasis that has a sort of sculptural piece with a drip ring on it. Gets about 105 most days in the summertime. So having both the visual and you know, water in the air, water vapor in the air, as well as the sound of it, helps to keep that space cool. And then there's some really wonderful sort of found object sculptures, water fountains that are built by the Otto Group. I think they're out of Philadelphia now. There's a picture of that drip ring in action. The kids can come out. There's actually a little flow of water that comes out and spirals into it. The main piece, of course, is this showroom building, which at the time it was built was the largest straw bale building. It's about 5,000 square feet. It's been much surpassed now, thankfully. And it has a fairly simple solar section, and really, you know, it's based on keeping the sun out in the summertime, and then during the day, and then at night, providing high ventilation so that heat that's accumulated can be released. Just a shot of the trellis here. These are all wine barrel staves. You can see quite a bit of trellising on the end there, and those are those high windows. And I will go to the roof. A fairly large photovoltaic array, and then this is actually not owned by them, but a utility company built these very large array. David remembers these things. I don't know how big it is, but it's it actually. What's the other wonderful thing about it is that when they have their Soulfest, their annual event in August, it provides this very important shade, which is really great. It can do both things. Just a couple of eco-resort projects that we kind of got through the master planning phase, and that's it. But obviously lots of fun to work at. This one is in Malawi, which is on a really beautiful freshwater lake with incredible fish diversity. There's actually a World Heritage Site just up and around the corner from this particular site. And resorts are being developed along it, and they're taking the water out of the lake. It's a freshwater lake. You know, all the villagers do that too. And then they pump their sewage just a little further out into the lake. So dealing with issues of wastewater was very important here. As well as, again, shade. These are actually fish drying racks, but frequently you see people sitting underneath these structures. So there was a bit of a swale to the site, so we worked with Elise Brewster, landscape architect, and water specialist, to develop sort of a first level of reed beds, and then this sort of planting zone down the middle that would take the storm water and filter it before it would sort of run out, you know, down back into the lake over here. And then having the buildings on the high point so they're getting breezes. We work with the local villagers, this is the chief over here, to discuss what kinds of things would work, you know, would be symbiotic for them, what kinds of things could be grown, what kinds of buildings they could build baskets out of, and actually what kinds of building materials they would work with. These are some typical ones. They actually they're really beautiful, and all of them are a little bit different, but working with the reed structures. And I tell you, all the concrete buildings are unbearable, but the mud huts with the thatch roofs can be quite comfortable. So we're working on a kind of, they don't have straw, but they have corn, so kind of rolled corn husk version. And I don't know how far they've gotten with it. We just suggested it. So we came up with these little sort of little village compound pieces, and each one would have its own outhouse, and they would come in these little pairs. And the composting toilets, I mean, actually are incredibly functional, and they provide a really important entity. I mean, they're actually, you know, they tend to scrape the sludge out of the wastewater treatment plants for fertilizer. So providing a clean, safe source of fertilizer as a byproduct of the waste treatment was really important. And this one is in Baja. This is the San Miguel Spiritual Retreat and Yoga Center. And again, an really beautiful location and really shaped by water. They get their rain in these huge sort of monsoon events called chubascos, and you can see it's really shaping the granite itself. Petroglyphs on this rock down here, really beautiful site. And so just using the water, it's actually, they were lucky enough to have springs at the top of the site in this mango grove, and so bringing the water through the site and kind of purifying it and celebrating it, and then all the way down at the end of the site, providing this black water swale that obviously is treating the water, but also providing a protection from the fire vectors that come up the mountain. There are some really beautiful rock figs, some natural features in the landscape. So as much as possible, we just sort of left them be and provided paths to them, and then the buildings themselves are working with native materials, because that's what's there and that's what works well. This is a chiname, just a woven stick that provides privacy but allows the breeze through. Lots of rock work, trellises, and then in some cases straw bale with an earthen finish, palapas, and then just a few centerpiece buildings, these kind of uplifting, slightly translucent roofs we were proposing. I won't go into it too much, but there's a image of the yoga hall at the end with a walking meditation around it. This is the front of our office, and solar is something that we work with a lot. We think of it as a sort of design tool sometimes. We don't own the building, but we installed these solar awnings with the blessings of our landlord. And they also move. They have two settings. Again, it actually raises up above the window, so it lets the winter sun in, and then in the summer you actually drop it, so you're cutting off a lot of that sun. This is not my car, but this is something, one of the presenters at this design retreat was the chief technical officer of Tesla Motors. And I thought because it's Indianapolis, I just had to show. I just had to show this thing. It's an all-electric car and high-performance vehicle. And it's really quite exciting, the technology that they're bringing to it. This is our version. This is our electric car, which is a little lower tech, but it's and with a less range and the whole business. But again, trying to work with these technologies, we try and experience them as much as possible. We have a windmill on our house, just to test it out and see what the foibles are. But the truth is that most of the time we just ride our bike. It's not very far. Residential architect like this, it's got a little plug instead of where the gas should go in. Yeah. We did a project with Timmins Design Group, also for the city of Palo Alto. They had a large photovoltaic project, sort of a demonstration project that they got a grant from, I think it was a federal grant from the Energy Department, and they looked at putting it on 3 sites. I'll just show you 2 of them quickly. Very simple buildings, but providing these kind of awnings with just a little bit of color and whatnot in the structure, which provides shade as well as a fairly large array on some community buildings. And then at this is their municipal site, so this is where all the city cars come and go. It's actually kind of an ugly building. So, and it's right on the highway. So we got kind of excited about the idea of doing these big tracking arrays that you could see as you're driving up and down Highway 101 as people were commuting. So there's also a very large parking rooftop installation, but these are the fun ones, and I think this just shows that what they would look like as they're spinning around. Our model maker put this thing together. Kind of goofy. Okay. So that should be, it's under construction and hopefully be done by the summertime. And the city council made them square instead of pinwheel, I'm sorry to say. This is a site in the Wrangell St. Elias National Park, in Alaska. Very different climate, very, very beautiful, very remote. Here's the winter sun from about 10 to 2. And then the summer, it never really gets dark. But we were working mostly, the main season there is May to October. So that's kind of design range we were working with. There's an existing building on the site that we're adding to, the kind of log cabin starting point. And then we looked to some of the buildings that were done locally for the Kennecott mine, copper mining up there, just in terms of how the dormers work, how things shed snow. And then it's actually a straw bale addition that we did, but it has, it has to have, everyone must stay in a log cabin when they go to Alaska, so it has these log coals. But what's great is that it's actually the waste product, right? They cut a square beam and you've got these round parts that are left over, so they're using them, and it actually, because it's a rain screen, it protects the bales better than just a plaster, actually. Just a quick section there of the main dining room. The owner had all these spruce beams that were salvaged from the site. Concrete floor, it's actually insulated below as well. And that's the shot. This actually cranks around to the south, but it also provides a nice view of the Nazina River. Okay. Let's see, this project, skipping down to Nevada here, this is the one that won the Committee on the Environment Award a 2 years ago. And it is a really interesting site. This is the Sierra Nevada mountain range here. Tahoe's kind of right over there in the corner. And on the other side is the sort of flat plain of the Carson Valley. So working with two very different environments on either side in this kind of transitional landscape. The idea is that from above, as you enter, you have a sense, you get the sense of the sort of flatness of the Carson plane behind you, and the landscape actually rolls up onto the roofs of the garage and guest house. Whereas from the low side, the building kind of juts out like the boulders, like these mountains beyond. These two wings, the garage guest house and the main building, form this courtyard space between them, which is really important in terms of providing a protected space. Nevada is incredibly hot or incredibly cold, and the winds come whistling down the mountain, so that here the guest house roof actually lift those winds up a little bit. And then there are photovoltaic panels on a trellis that also shade that space in the center there. A diagram of the heating and cooling and energy generation. These are those panels that are adjustable. I think I'll show you in another slide. And there's an additional array up here that is laminated onto the roof. Again, visibility was very important. There are not any neighbors in these shots, but there are neighbors, and how it's perceived, there's a elaborate design review process, was all very important. And then down here are solar hot water panels, and they're, because of the grade change, they're actually dropped below the level of the terrace. So you don't perceive them from the terrace itself, but they're actually gathering quite a bit of sun, and those feed, I think there's another, I'm sorry, there's a solar on the roof. That's the only place you can see it from. And these tilting solar panels, and these adjust. The other nice thing about that, of course, is that, which we didn't think about, but that they actually shed the snow in the wintertime as well, because they're cranked up a little bit. So just a diagram of the solar hot water heating system, the array of solar hot water, of heaters. They're heating a glycol, a solar fluid. It goes through the solar storage tank where domestic is taken off, and then it is feeding these loops that are in a sand bed underneath the slabs of the buildings. So you can see them stapled in there, and that becomes your storage for the heat. So the issue is you can get a week of cold weather and you're not getting any heat, but it's having stored that up, it's still radiating over time. It actually takes about 3 weeks for the system to come up to heat, to a temperature. You turn it on in beginning of October, something like that, and then it continues to radiate. Occasionally it doesn't get quite enough, and there are some backup systems. But with the normal weather cycle there, it works quite well. Additionally, just sort of traditional passive solar thermal storage in a concrete floor, concrete topping slab. This is in the living room with a fair amount of shading and overhang. So then in the summertime you get just about no light, no daylight at all. Not daylight, excuse me, no solar gain. This house has a number of different building systems. As a demonstration house, that was important, but given how long it took to build, I wouldn't really recommend that. It has insulated concrete forms where it's retaining on the lower level, straw bale on this main level. It has structural insulated panels for the roofs. It's got lots of stuff. The main portion, including the straw bale, is coated with a soil cement from the soils that were on site. They were actually tested and adjusted only slightly. They work really well for that. And then you also get the sense, the sort of color sense that it is really one with the site. A couple of interior shots, the obligatory truth window. This one actually something we had sitting around the office. Never seen a corner one before, and now I know why, because it's really hard to do a corner straw bale tooth window. But you can see that same sprayed earth finish is on the interior, but it's just troweled smooth. I have a couple more shots of that. In the hallway, again, the lower level is kind of buried here. So there are thick glass panels in the floor here that allow light to transfer down there. There's an example of that on the lower level. And then just about we found all sorts of wonderful salvaged wood, and we used kind of all the parts of it. They milled them up, and then we used the offcuts as paneling and salvaged doors and on and on. Just a view of the kitchen. The countertop was made by Counter Productions. I think they have a new name and probably a new owner now in Berkeley. And this particular one, the owner actually found the glass in the salvage yard, in an ore cart. Glass used to be made with manganese, which turns this sort of pinky purple in the sun. So you could actually, read bottoms of jars and whatnot. And this is this great piece that has a melon holder, olive pits, or something like that. It was kind of a mistake, but a happy mistake. And then just finally, the sun, what do I call it? Sort of a greenhouse here off of the south corner of the building, so the owners could grow lemons and whatnot in the wintertime. And we knew we had to shade it some way, right? You can't have that much glass in the summer without shading it. And we didn't really know how, but the builder's a glider pilot. And so he said, just go get those flaps. And so we went to the airplane, graveyard, small airplane graveyard, and they have all these flaps. The new ones are incredibly, ones that actually function are incredibly expensive. But the ones that are a little dinged up and can't fly anymore are about $40 a piece. And so those were sandblasted and it became our shading fins. And just a few other details. The trellis is supported on salvage railroad track. And just sort of in the theme of it, we used ore cart wheels that I found at that same salvage yard to support them in various ways. And this is actually copper mining screen. And the copper pebbles are sort of rusted into the screen. And they have this great greenish, I can't tell when the light's on, cast to them, which we had our metal fabricator bend them up and make into lights. And a final view of that project. Whew, how are we doing? Earth and straw materials we like to work with a lot. Again, well, for obvious reasons, but straw bale in particular, well, there sure is a lot of it, and it used to be burned. I can't do that in California anymore. I don't know about Indiana. Anybody know? They don't burn it here? Uh-huh. Well, that's good too. But so bales are a commonly available material. We didn't have any problem even getting them in Alaska. And Baja is not a problem. It's amazing. There's two basic types. You guys probably all know this, but there's a load bearing where it's actually taking the weight of the roof, and then non-load bearing where the weight of the roof is taken by something else. This is a system that we like to use where you're using I-joists to hold up the rest of the structure, and the bale is just infill. And it's a fairly lightweight and efficient way to do that and still deal with the depth of the bale. This one, incidentally, is the project we did up in the foothills, slightly less seismic zone. And it actually has the pinning is done on the outside using bamboo tied to the bales on either side. But it's a fairly simple single-story structure. Moisture, of course, is the big bugaboo in bale construction, but frankly, it's not that different in wood framing. You need to be really careful about controlling it, and usually you say good hat and good shoes and a coat that breathes. So, nice deep overhang is a good foundation, keeping it off the ground, and then allowing whatever moisture is getting in there to breathe. No Tyvek. This is the mobile home slide, but I think it's just availability. And then sprayed earth is something that we've gotten excited about, especially in combination with straw bale. This is just a gunite rig, and it's been slightly converted to take the larger aggregate and clay bits that come with earth construction. Here it is being sprayed in a monolithic form, an 18-inch thick wall. You can see the rebar skins in there. And then here it is being sprayed directly onto the bale wall. You can see building paper. That's actually the wood portions, but it's sprayed over the entire thing, and it forms this really amazing bond with the bale, but just by the pressure and the fact that it's sort of friable on the edge there. On this particular project, we did a test wall, so that the building department would be happy with the in-plane loading, and the engineer figured out that if it supported its own weight, that would be a factor of safety of 4. And so he rigged up this thing and tipped it over, and it was just, I mean, it's unbelievably strong. It actually had to make a pool on top of it to break it, an additional, I think it was about 8,000 pounds. So that project is a residence in Mill Valley, a fairly modest residence, and like a lot of our straw bale projects, it's a bit of a hybrid. It has wood framing on the clear story and in a few places where there's plumbing. But the depth of the wall and the insulation and all the qualities of the straw bale, I think, really shine in this project. And again, this is sprayed inside and outside, troweled smooth, and then grout washed. The interior has what we call it the Great Wall of Storage, but it actually is a shear wall. So it's for the building department, helping to take the load off of the bales. And then they're built with 2x12, so there's enough depth that we could actually have storage in what is otherwise a fairly small footprint. It's about 1,800 square feet. It's actually designed to have a loft, kind of office loft in the end, which was never built. And eucalyptus columns that that the owners actually harvested on the other side of the site. And part of the wall of storage is a one long track that supports all the doors. These were from Stanford University, carefully sealed to deal with a lead issue. And then because the bedrooms are fairly tiny, there's sort of 4 of them lined up in a row, the 2 girls' rooms have these screens between them that it's a corkboard and a chalkboard and whiteboard. So when they're getting along, they can be slid open, and you've got one big room, and when they're not getting along, then they have corkboard and chalkboard and whiteboard. And built-in composting, again, really simple, just restaurant equipment dropped in a butcher block here, and then in the near the kitchen sink in the backsplash, these hatches that for your recyclables go out into them, and then you can fetch them from the outside, and the kids always like that part. And then really trying to promote outdoor living. It's a very, very foggy area much of the time, so having an amenity like an outdoor fireplace really brings people outside, and even though the house is quite small, they have that much more space to work with and enjoy. I'll go through these really quickly. This is something called the shed at the Eco House that was done as a student project through UC Berkeley. And this is an example of incorporating way too many materials in way too small a space, because it took a whole extra year of Saturdays to put it all together. But living roof, it has straw bale, it has cob, it has rammed earth, it has, you name it. It's quite amazing. Lots of really beautiful details. Sort of lovingly made. Even they had to have bars on the window, so they had an artist make these lovely metal flowers. Salvage door here. Even the glass above this wall was melted down from bottles. This project is up in the Level Valley as another residence, and it is, this is actually a sprayed earth house known by its acronym PZE. So the walls that you see here in the lighter color are sprayed earth. There's a few rammed earth pieces, these columns and the fireplace. Rammed earth is incredibly labor intensive, and especially in California that translates to incredibly expensive, period. So this is a more affordable version of it. And we really tried to use the sprayed earth to its advantage. So it actually retains quite well. So it's berming into the hill on both sides here, retaining on the lower edge, and then creating this sort of zone of living in what is otherwise a fairly steep hillside, so that you can see it on the retaining side. And then on the western edge over here, we're sort of bending around the contour. Beautiful views, but really quite hot, west facing. So having a very deep loggia to protect that side, and then windows above it. Actually, the light bounces off of the roof up through these windows and onto the ceiling. And then by the time it's sunset, you get this really beautiful light streaking through the room. Just a detail of the fireplace, pretty subtle rammed earth walls. We use the same material, so there's very little contrast there. And then the end of that main hall, again, it's north-south, is sort of long, is its long axis. So using a sort of trick of pulling down the kitchen to get a big south-facing window above, and then in the winter you really get light all the way through that space. I can keep going a little bit. I'm never going to get through these things. A tower in the front. It was something we sort of struggled with a little bit, but it actually shades, in addition to providing a nice view up there, shades this space, the outdoor space, really nicely. The master bedroom wing with a sprayed earth piece on the end, and then again where we have plumbing and other complications using wood framing and also for contrast, but still getting light in from the south from those high windows, as you can see up here. And then more recycled glass countertop, and very simple materials that just sort of are have a sort of beauty in themselves. These tiles actually were made out of the same material as the earth walls as well. You screed it, you spray it up, and then you scrape it off. It gives you a lot of leftover material. So some of them are made into these blocks. So wood is something I think David and I both feel very strongly it's a really precious material. And then rather than stick framing and covering it all up with stucco, that you can really appreciate it. Or you can carve it into shorts if you've got a really nice chunk of wood, I guess. I think this supposedly is a single redwood tree coming out of the Mendocino area, and I just don't think we can be doing that anymore. This sort of preciousness of wood is something I looked at when I was in Europe, and they ran out of their forest a long time ago. So every piece is really carefully sort of tended to. Even in the salvage yard, in the lumber yards, they have old wood. That whole stack of recycled wood that you can pick through as well. And then again, there are numerous sources for recycled wood. I'm sure there are some here as well. These are pickle barrels from Vlasic Pickles in Wisconsin that were really disgusting looking on the outside, but we split them and use them. They're actually not particularly structural, but in the ceiling sheathing here, and you get a little bit of salt streaking. And luckily it doesn't smell too much like pickles, but it has that sort of patina, inherently in it. This project is up in the Wallala area, Mendocino County, where they've done a lot of logging, and really showing off the wood was very important here. It's both sort of in the trees, it actually overlooks the ocean, but because of that tradition, showing it off, and 95% of the wood that's in the project is visible. The main form is much like these wind-blown hedgerows shaped by that. And we actually looked at it, excuse me, at UC Berkeley wind tunnel to study that and the effects of it and to create comfortable outdoor space. Urban area, Belmont, California, and it was about a 5,000 square foot lot. Is that right? Sound right? And it has 2 existing really beautiful oak trees. I think no one else could figure out how to work around the oak trees. So that was the main thing we were trying to do. So it becomes a kind of a roadhouse on this main sort of busy road, and then on the back side it has a much more kind of rural sense to it as it's tucked into the trees. And then really working, that both of the owners are strong advocates of solar technologies, particularly bicycles. They're a big thing, bicycle commuting in the South Bay. And they actually moved to this neighborhood so that they could have an easier bicycle commute. And incorporates the solar hot water system I talked about on the other project. You can see the sand beds on these lower levels, as well as photovoltaics, and then daylighting in the middle, and has these sort of courtyard spaces on the front here with an additional sort of privacy screen, so you could get ventilation even though you're still, kind of one with the road there in front. And again, a whole lot of salvaged wood in this project with high clerestory, so it really highlights that. And then in the middle, as this building is kind of climbing the hill and working its way around these 2 oak trees, is this tower piece that is both providing natural ventilation for the whole building as well as bringing daylight in. A little salvage window up there, all salvage trusses, and it actually has a glass floor, again, for daylight. And as you work your way up, it becomes, again, every square foot is used, it becomes the library. At the end of this is a study, and it's also access to the roof deck out this way. And even as you go into the kids' rooms, the kids' rooms themselves are fairly small, but there's a kind of wide spot in the hall that becomes a common space that they can use. There are these desks that flip up out of the walls for study space, and it's the restroom access, and it's the laundry room, and it performs lots of different functions, as well as accessing that kind of the back garden side. And then more salvage materials, these ones from an elementary school in Berkeley, and you can see that they've had many, many years of kids throwing balls through the window. As every single window pane, there seems to be a different material. Of course, we had to leave that. And then all of the TNG and the eaves is from teardowns in the South Bay. And the clients very kindly let us leave that. So you don't see it very often, but when you look up, you get a sense of the origins of this building. This is a psychotherapy office. This is actually in our town of Albany. And not a very easy project. We had liked transparency and ventilation and these kinds of things, but when you have the acoustic privacy needs of a psychotherapy office as a difficult combination. So we worked with that, and we worked with this madrone tree that somehow became the kind of icon of the project. We harvested this with the owners. It actually comes from one tree, all these pieces, and then became the branches on the stairwell inside as well. Sort of used every little bit of it. Again, a vinegar barrel on the fir here, and then just really trying to bring in daylight in as many places as possible, kind of borrowing it through the office and then into the window, into this sort of central atrium space. And then it has a fairly sizable photovoltaic array on the top, which has battery backup because, you know, when you're doing psychotherapy, you don't want to you don't want to have a sudden change like that. So it's all set. Redux is kind of the word we like to use for recycling, for rebirth of sometimes materials, sometimes whole buildings. We are certainly frequenters of our local salvage yards, this one Urban Ore, and here Omega Salvage. Steve gives us the frequent buyer discount, very kind of him. And just on the entry of that project I was talking about before, Port Orford cedar. These are steel sash windows here and there in an unheated entry, so we could get away with single glazing. Wine tank bottoms for in this custom door, and even the light fixture came from Omega Salvage. This is on the level of an entire building. This is a really horrible building, sort of medical office building called Pain Net. You can see it there, that we transformed into financial offices and kind of brought the green to it. Mostly, actually, you know, it was kind of a landscape transformance in the parking lot, which obviously had to keep some parking. So again, we work with Elise Brewster on that portion. And then in terms of the building, there's an existing courtyard. We worked on just bringing in daylight and enlivening the spaces that way. And then on this particular corner, this is the Ocean View District. This is Delaware Street in Berkeley. Having a kind of an anchor, a wood-sided anchor that related to these existing historic buildings became important there. But in terms of this space, in the center is kind of the hub of the financial offices, and when they have a client come, it's all about, you know, this central space, and so it has very carefully controlled light, and it has a sort of cupola in the middle, opening up to the courtyard on the one side. On the other side, it opens to the entry, but you can close it off completely with these doors. And then when the client goes away, you open the doors, and it's part of the entire office, becomes part of the space, and really opens up to the garden on both sides. This is the entry piece that it opens up onto. Every workstation, you know, even this one here is borrowing some light from the conference room, so bringing daylight as much as possible to every piece. There's a final view of that. This is, how are we doing on time? I'm going to skip this one, so. Maybe I'll skip that one too. We just work on images there for a second. Let's see. Let me just point out in this project, we're working both with form, but also trying to integrate photovoltaics in unusual ways. This one has the peel and stick roofing on a curved building. The buildings are generally opening up to the north because the client is an artist, and bringing the north light in was very important. And trying to create sort of courtyard spaces and work with the solar aspects of this project in Bolinas was very important. So there's that main courtyard. The building itself is very small. It's about a 1,600 square foot building. Oh, sorry. With a 300 square foot guest unit plus this artist studio. So we sort of treated it like you know, it's very dense, like a barge with consolidated solar hot water in the bottom. And then the section changes as you move through it. So here's the dining bay with daylight illuminating the living spaces, and then the entry piece and the breezeway. So even though it's very small, it's changing quite a bit as you move through that common section. Just that dining bay. There it is from the kitchen side, providing daylight deep into that space. The owner has many personal touches here. This is the sink from her childhood home in Philadelphia. And then she did these glass blocks, some of which incorporated shoes that she found on the beach, and it becomes a reverse of that and kind of a ghost. And those are incorporated in the floor, and then we had some leftover ones, so they showed up in various places. There's some more in another bathroom, and then again, borrowing light here from the entry on the other side. Too hard to explain in a short amount of time. But there's Nessie out there, photographer cribbed in. You didn't know there was a Loch Ness Monster in the Bolinas Lagoon, did you? A park project that we're working on. Oh God, it's too much to explain, but it's there was an existing, a sort of a funny chunk of rural land in the city of San Pablo, which is a fairly dense, very urban, slightly impoverished town. And having this scrap of rural land was very important to them. So the environmental education building, which is actually mostly for aftercare, used the kind of basic structure of that with an added wing onto it. And it actually will use all of the wood from the barn, but obviously with a more insulated structure. This is one just using SIP panels, structural insulated panels. And then it has a very large photovoltaic array for such a small building, about almost 6 kilowatts. And that will power the entire park, likely on an annually average basis. Little solar hot water heater here on top of the dormer, which is also providing ventilation. Again, very simple, hopefully inexpensive building. We'll see, it goes to bid next month. And then at the end, so this is the heated space here, and the end there's a kind of a classroom that has no heat to it, but it provides an outdoor space. So these doors can be slid open, and it connects to the park on both sides. Another project we're working on, this is in residence in China, using an insulated rammed earth system. It's something that's probably too expensive to do here, but actually working on it in Canada a lot. And this building, again, this is just the living room, very simple solar section, but the buildings themselves are formed so that they take advantage of the summer breezes which come from the south and actually compress them, which increases airspeed. So it cools it off in the summertime. Lots of overhangs for the high sun. And then in the winter, the winds actually come from the north off of the river and are deflected around these buildings while letting in the lower winter sun. I'll just go through these quickly. This is some analysis we did for a green classroom building for the Carmel School District. It's public school, and they happen to have a good fortune of having an amazing habitat project that incorporates a garden. So these walk through solar aspect and whatnot. I think the view shed is supposed to move. Never mind. Oh, here we go. Just to showing the shadows. I mean, these are some fairly simple tools that we can use to study how much light and insulation there is, looking at temperature and rainfall, and then sort of putting those pieces together and looking at which passive design strategies might work for any particular project. And I don't need to go through green classroom benefits too much. But we developed 3 options and then had to cut the program in half. What happened was the school district, they decided that maybe they didn't want a building right in the middle of this 10-acre piece of land that they mostly use for habitat. So we came up with the idea that the building itself could be relocatable, so that they could have the building where they wanted it, which is in the garden. But if at some later point the school district wanted to move it, that was a possibility. So we're actually working on creating a green classroom that is maybe replicatable as well. So these are modular components, very crude sketch of how it fits into the garden space here, or the main entry here, and a path from the adjacent middle school over there. And sort of one kind of expandable classroom building with cooking kitchen in it, a dining terrace. There's actually a pizza oven that they have existing over there, and a storage bar. And then you enter in this way under a sort of photovoltaic array with everything displayed, opening up to the south. On the west wall, where they're going to get a large amount of sun. Usually in the morning it's foggy, but in the afternoon they do get quite a bit of gain. There will be a living wall incorporated into that, as well as living roofs that extend the sense of the habitat, which is just across the way over here. Having trellises and toldos, awnings that pull back and can be opened or closed on that dining trellis side. And then again, having this high clerestory both for ventilation and to control the daylighting very carefully was important. Just some examples. We did the daylighting study model. We've actually tweaked it a little bit since then. And this is just showing direct winter gain, I think. It's coming through there. I just got to keep going. Simple natural ventilation, actually in a kitchen environment, that was particularly important piece that we were looking at. And having the breezeway roof, incorporating a wind tower, having everything on display, rainwater harvesting, composting, truth windows so that you can see the systems and have the building be a teaching tool. And this is the model that we built of it to get through the school district, basically. So, okay, I'm just going to end with this slide. I know you all did the 2010 initiative, but I think that, it's really exciting to see this sort of momentum building and tools of analysis out there. I mean, the fact that you have a daylighting lab and you have a heliodon, those are incredible tools. And I think if you can start with them as design tools, if you can bring them as kind of, bring your design as an ill-formed thing and kind of play with it at that level, and look at integrating systems as much as possible at the beginning, that these goals are really achievable. Okay, sorry, a bit long there. But, these are just some websites that I might be interested in. Sorry, go ahead.